In this lesson, we're going to be talking about debugging. Now, you may be thinking that debugging isn't something that you need to know because we're not talking about writing programs and doing big programming tasks. The thing about debugging, though, is if you're going to be looking at malware, for example, or if you're going to be writing program exploits, you need to be familiar with using debuggers and how they work and how they're all laid out and what you're actually looking at. It's also really helpful to be familiar with assembly language because that's the language that you are going to be looking at once you're inside the debugger. So what we're going to be looking at here is a couple of different debuggers under Windows. First thing I'm going to do is I'm going to open up a program. And I'm going to grab this one here. And you can see that what OllyDbg is doing is it's launched the program, and OllyDbg is a free debugger that you can get. There are a couple of different versions of it now. 2.0. something is the most recent version, and that's the one I'm working with at the moment. So here's the assembly language code that we are looking at, and this is the actual program. This is what's sitting on the disk. And of course, this is the mnemonic version of that code. It's not the binary that you would actually be looking at on disk. This has been translated to something that's somewhat human readable. So in the right-hand corner, you can see the registers, and there's a couple of useful ones to make note of. There's ESP, which is the stack pointer. That's the current position in the stack. And you've got the base pointer, which is the bottom of the stack. And you've also got the EIP, which is the instruction pointer. So that's the place in memory where we are executing code from, and that's the current instruction that we're sitting on. You can see it's 401130, and if you look in the upper left, you'll see all of the addresses down the left-hand side, and that's 401130 as well that we're sitting on. Now, we're just kind of sitting there because that's what the debugger is there for. It's launched the program, it's got to the starting point, and it's stopped waiting to figure out what we want to do. So there are a few things. We could just run the application, and this would be useful if we had breakpoints set up. So we could just let it run and go to a breakpoint, at which point we could take a look at what's actually going on. We can do step-by-step execution of the program. So I'm going to do steps here, and you can see the stack pointer and the base pointer down underneath the execution, the main thread. And you can also see I'm moving slowly through the threaded object here, or the program that we're running. And now here it's going to call a particular function that is at the address 401020, and so we should jump off to that address. And now it's asking me, because this is actually a server, so it's asking me whether I want to allow access for that server to listen, and I'm going to say yes. We're at a point now where we're not actually doing anything because the program is waiting for input. But these are sort of common steps that you would take as you're debugging. You would want to know how to just step by step go through your program one line at a time or one instruction at a time. And you would do that using the step into, step over, or trace into, those different commands here. You can also see in a couple of other sections of this window, you can see the different addresses and what's located in them. So if you want to see what's in memory or what's at any particular point in memory, and you want to see both the ASCII and the hex, you would use this window in the lower left. And in the lower right, we've got a different section of memory, and this is where the actual code would be stored, or a different portion of the code would be stored. And it looks like these are all different libraries here. So this is a pretty typical debugger setup. Now I'm going to close the debugger, and it's going to stop the program. And so it's got the process closed now, and since there's nothing loaded up, all of the windows are blank. Now what I'm going to do is I'm going to show you the same thing in a different debugger. This is the immunity debugger. You're probably not going to find an awful lot that's going to be hugely surprising to you when you go from one debugger to another. The first thing that you notice is its color. There's color coding to make understanding what's going on a little bit easier. So you can see the actual instructions are in a green. We can see load instructions and move instructions and add instructions and then some calls and returns. And so any place where we're jumping out of the current execution path, so like a call or a return or a jump, those are in red. And the white ones are registers. And we've also got different chunks of memory. Those are different colors, so addresses are different colors, and just raw pieces of information are different colors as well. You can see on the right-hand side, we've got the same thing more or less as what we had with OllyDbg, and you can see the registers, and you can see the base pointer and the stack pointer and the instruction pointer. In this case, the instruction pointer has stopped inside NTDLL, which would be a dynamic library, and it's holding on there. Same thing here, though. We could just let it run, and we can step into. So I can just click through here and let this process run. You can see the instruction pointer on the right-hand side is incrementing. But pretty much the same thing as what we had previously with the OllyDbg. So it takes some getting used to how all of this works, and this is certainly not something we can do in a short lesson here. It's something that you need to spend a lot of time digging into and learning some assembly language and seeing how all of it works. And once you get to the point where you understand assembly language a little bit better and can see what's happening inside the program as it actually executes, you could move towards doing things like analyzing malware inside a debugger and seeing what the code is actually doing. Because without the source code, this is the only thing that we've got. We've got the actual executable, and you need to be able to understand what the executable is actually doing. And there's no way of actually masking that. The executable is going to do what the executable is going to do. We can't play around with that inside the debugger because you're going to be able to see every instruction as it processes. That's just how these debuggers work. So that's why I wanted to introduce just a couple of debuggers to you, and there's certainly other debuggers as well. Microsoft's got a debugger. There's one called IDA Pro, which is kind of top of the line from a debugger standpoint. On the Linux side or Unix-like side, we've got GDB, which would be a debugger, and there are graphical versions as well, like DDD would be a graphical version of GDB. So we've got different types of debuggers. They run on different operating systems, but ultimately they have the same object in mind and the same core functionality, which is to run through a program and show you instruction by instruction what's happening as well as what's going on in memory.